on, my policy will be homework assignments will just be posted on Foxtail. Okay, so whatever it is that's posted, I'll just take either PDF or some screenshots or something and post the homework.
Will there be something for the answer key to check over?
Let me see what I can do on that. Maybe so. Yeah. Okay. Any other questions, just course related? So just in review, there was a mistake on Foxtail with the assignment. It's fixed now. It doesn't go through 130 or whatever it was. It was only supposed to go through like 117, and then there's a couple more problems after that were added on. So the 130 has been changed to 117, and so hopefully that fixed all the problems. If there are any more, let me know. And we're just gonna, in some sense, get away from these problem sets because they make my head hurt. Okay, any questions? Or just homework questions? Yes, sir.
So between 103 and 106,
yes,
taking the limits using the left and right hand.
Yep.
I don't quite understand how we do that.
Okay, sure. So should we start with 103? Okay. 103. We have the limit as x goes to -2 from the left of 2x squared plus 7x minus 4 divided by x squared plus x minus 2. All right. So first of all, they say, well, just plug in the -2 and just see what you get. And let's see if we can do this really quick. -2 squared is 4. So this is 8 minus 14. Let's see. Is that correct?
8 plus 14 minus 4.
Yeah, minus 14 minus 4. So 8. Okay, so -10. And the bottom is, so it's 4 minus 2 minus 2. So 0. Okay, so we've got some number over 0. And this is suggestive in a way that this thing might be going to plus or minus infinity. Okay, let me explain for a second. And we'll get to talk about this a little bit more in the next few sections as well. But let's look at this. This is the limit as x goes to -2 from the left of, if I factor this, well, first of all, can I factor the top? Yeah, what does it factor to?
2x minus 1 and then x plus 4.
Okay, so we get 2x squared plus 8x minus 1x, 7x minus 4. Perfect. And then can we factor the bottom? How about x plus 2x minus 1? Okay. So now that we have this all factored, the key here is what makes the bottom 0? Okay. And in this case, two things would make the bottom 0, a 1 or a -2. Correct? And then what I want to ask is, like, -2 is the place where I'm concerned. And I say, is there also an x plus 2 on top to, so to speak, cancel it out? And there's not. And since there's not, that would be the way that we would kind of like find the normal limit, is canceling the x plus 2's. And what that means is if there's an x plus 2 on top and bottom, it means that there's a hole in the graph. If there is not an x plus 2 on top and bottom, then we're talking about an asymptote. Okay, and so like I said, we'll get to talk about this a little bit more in later sections. But so what's going to happen is you're saying, okay, we're coming in from the left. And the left means I'm taking something slightly smaller than -2, right? So like -2.1, something like that. So if I plug in something slightly smaller than -2, I already know this isn't a hole in the graph. So if I have kind of a problem spot on the bottom where it's going to 0, that's going to make it either get really big or really small. And now my question is just, well, which is it? So if I plugged in something slightly smaller than -2, what happens on top? So I'm going to just do some squiggles here because I'm just trying to figure this out. So if I plug in something a little bit smaller than -2, then something a little smaller than -2 times 2 minus 1, is that positive or negative? Yeah, it's negative. So it's something negative, and then something a little bit smaller than -2 plus 4 is positive. Something a little bit smaller than -2 plus 2 is just barely negative. And then something a little bit smaller than -2 minus 1 is still negative. So we've got a negative times a positive over a negative times a negative. On the bottom, that's positive. On the top, it's negative. So it's negative infinity. Okay, now, if there was an x plus 2 up here, then it's not going to be plus or minus infinity, right? Then they just cancel and things are wonderful and we get our normal limit. If there is not an x plus 2 to match it on the top, then the answer is plus or minus infinity, and we just have to figure out which of the two isn't. Does that make sense to everybody? Yeah.
So if it was x goes to -2 on the right side, we would just plug in a number a little bit bigger than 2.
A little bit bigger than -2. Yeah, so like -1.9 if you like. But yeah, so I don't actually take a real number and plug it in. I just take, so in my mind, just slightly bigger than -2 and see what happens. Other questions? Does that answer your question on kind of that set?
Yeah.
Because I'm sure that they're all similar in that there's nothing on top to cancel out the bad.
I think it's actually the same equation.
Oh, really? And they just give different
Just different limits.
numbers? Yeah, right. Yeah. Yes, sir.
127 and 129.
127 and 129.
Squeeze here.
Okay.
You said we're not hearing everything, right?
I think so. I would have to actually check to make sure what it is now.
It's 83 to 117 odds.
Yep.
118 to
Yeah, that's right. So those aren't assigned anymore. Still interesting. If you want to do it, we can, but we don't have to. Let's at least get through the ones for sure that are assigned first, and then if you're interested, we can do it. Other questions? Yes.
Part 99.
Yes. Just 99 in general? Okay. Yes. So 99. We have the limit as theta goes to pi of sine of theta over tangent of theta. Okay, so the theta is going to pi, and then, so I guess the question is, what's sine of pi? sine of pi is 0, right? So we get 0 on top, and tangent of pi is, it's also 0. So we get 0 over 0. So we're in a situation where we need to do something a little bit different. Okay, so what we can do is we can rewrite tangent. So this is the limit as theta goes to pi of sine of theta divided by, well, tangent of theta is the same as sine of theta divided by cosine of theta. So now we've kind of got something divided by a fraction, so I could flip and multiply, and I get the limit as theta goes to pi of sine of theta divided by, I suppose, just 1 times cosine of theta divided by sine of theta. And now we can cancel the sine thetas. And we're just left with the limit as theta goes to pi of cosine of theta. And now we just need to know, okay, what is cosine of pi? Cosine of pi is -1, right? -1. And so that's it. Other questions? Anything from people online?
So when we're asked on like number 120,
Yeah.
it says, so it gives us the graph and then limit as x goes to 0, f of x times g of x over 3. So we plug in the zeros to both those equations, multiply them together and find that point, or
Yeah, so like the limit of as x goes to 0, f of x times g of x over 3 is the limit as x goes to 0 of f of x times the limit as x goes to 0 of g of x over 3. And so then you can just find each of those individually, which it looks like it's sort of 1 and is that like -3, it looks like, over 3. So 1 times -3 over 3. So it looks like it would be like -1, right? Yeah. Anything else? Yes.
85.
Sure. So 85, we've got the limit as x goes to -2. Limit x goes to -2 of the square root x squared minus 6x plus 3. Okay, so there's kind of 2 ways that I could explain this. And the first one's really simple, and that is that, well, this is just a nice function, so to speak, because it's a polynomial function, and then square root is also a nice function. But one thing that we know is that limits can move inside and out of powers. Okay, so this is really just a power. It's just limit x goes to -2 of x squared minus 6x plus 3 to the 1/2 power. right? And one of the limit laws tells us that we can kind of move limits inside and out of powers. So I can move that limit inside if I'd like to and just say that this is the square root of the limit as x goes to -2 of x squared minus 6x plus 3, which of course is the square root of, I could just plug in the -2 at this point. Really, the limit laws tell me a lot more than that. The limit laws say I can distribute this limit over this triple addition, so to speak, but I don't want to go through and write limit. We get the idea. This is a polynomial. Polynomials are nice in that if I'm taking the limit of a polynomial, I just have to plug in the number, right? And so that's what I'm going to do, just plug in the -2, and if I do, I get 4. -2 times -6 is plus 12, plus 3. And so what do we get here? Square root of 16 plus 3 is 19. So square root 19. And then, so you might ask the question, okay, you moved the limit through the square root. Did you have to? Or could you just have plugged in the -2? Well, obviously, if I would have just plugged in the -2, I get the right answer. But can you always just do that? And the answer is yes, as long as you're not ever creating division by 0. Okay, that's kind of the bad thing you can do when taking a limit, is kind of create a situation where the denominator becomes 0. And when you do that, then you have to be a little bit more careful. But as long as you're kind of preserving that plugging in the -2 doesn't really cause any division by 0, it just kind of all falls out, then everything's fine and you can just plug it in. So that's kind of what you need to remember in general. Other questions?
We do 109.
Sure. 109. We have the limit as x goes to 6 of f of x plus 1/3 of g of x. Okay, so it says in the following exercises, assume that the limit as x goes to 6 of f of x is 4. We've got the limit as x goes to 6 of g of x is 9. And the limit, oh, I guess we don't need that one. Okay, so we've got this. Yeah, so what the limit laws basically tell us is that I can distribute the limit across an addition sign, right? So instead of this guy, I can write this as the limit as x goes to 6 of f of x plus the limit as x goes to 6 of 1/3 of g of x. Okay, obviously this one we already know, that's exactly 4. This one we don't know, but another rule of limits is that constants can pass through limits. Okay, so the limit, the 1/3 can move outside of the limit, and we could just write this as the limit as x goes to 6 of f of x plus 1/3, the limit as x goes to 6 of g of x, which is, this one we know is 4 plus 1/3, and this one we know is 9. And so we get 4 plus 3, 7. Sound good? Other questions? Okay, since we have some extra time, and I feels like we should do something fun with it, let me share something with you. I could share something just kind of cool, or I could share kind of a riddle. I think I'll go more with the riddle side. So I don't know if you guys like riddles or not, but like this is my favorite riddle of all time. And if you've already heard it, I apologize. That's too bad because it's very fun to solve. But if you haven't heard it, try to actually solve it yourself. Don't look it up online. It's cheating. It's a terrible thing. So here's like my favorite riddle of all time. Tragically, somebody very mean has poisoned you, and but they give you a way to save your own life. And so they bring you into a room, and they set before you 12 pills. Okay, the 12 pills look exactly the same. They smell exactly the same. They taste exactly the same. You can't tell them apart at all. What they tell you is that one of these pills is the antidote, okay, to your poisoning. And what they give you is, if you're familiar with a balance scales, they give you a balance scales, and they say you're allowed to use the balance scales 3 times. Okay, all that they're going to tell you about the one pill that is the antidote is it weighs different than the rest of the pills. 11 of the pills weigh the same. The one that is the antidote weighs different than the rest. Now, that doesn't mean it's heavier, and it doesn't mean it's lighter. It's just different. So the 11 pills weigh the same. The one is different. You get to use the balance scales 3 times. And at the end of those 3 times, you need to know which is the pill you should take. And you only get to take 1. Okay? So, you just grab them all and shove them in your mouth. Let's just assume that the other 11 are certain death on the spot. Okay. But good question. I've thought of that as well. But it ruins the game. So what should you do? Let me start with something just to show you what you can't do. Okay. Let's say I took 6 pills and put them on this side, and I took another 6 pills and I put them on this side. Okay. So now the balance goes, what did you just learn? Nothing. Because either it's a heavy pill and it's over here, or it's a light pill and it's over here. So you just learned that one of the pills is the pill. Yeah, we knew that already. So that didn't help. Does that make sense to everybody? So it's no good to just like weigh 6 and 6. You don't learn anything. So but you only get to use it 3 times. And at the end of the 3 times, you need to know which one's the right one. Okay. This is a fun problem if you've never seen it before. Has anybody seen this before? Oh, excellent. Okay. Let's see if anybody can solve this problem next time. I will give you a hint. You probably aren't going to be able to do it just in your head. You might have to use a piece of paper and pencil to think about it a little bit. Anyway, so that's a fun problem to think about between now and Friday. Any other questions about homework, class in general? Okay, I promise you we won't be getting out early every time. I'm sure that soon enough we'll have plenty of problems that we want to talk about as we get a little bit deeper in. So just as a reminder, homework is changing slightly, okay? And we're gonna all be on literally the same page when it comes to homework, and I'll get everything up to date online. Okay, if no more questions, I won't keep you. That's it for today. I will see everybody on Friday.
Two pills.
What's that?
You start with 2 pills. Way 2 pills.
Oh, I'm not going to tell you.
Either because you get lucky and you put 2 pills that are different, right? And so you know one